So one of the last subtopics that we are looking at is on the pie charts. So this is another way what we have actually seen the line plots. We have actually seen the scatter plot. We have seen the bar plot, and now we are actually looking at the pie charts. So different charts are useful to display different data effectively. So pie chart is, of course, is a circular statistical chart, and of course it is used to display the percentage distribution. So the overall whatever value is 100%, then if you want to show in terms of the percentage distribution of a categorical variable, then you can actually do this. So look here, actually the variables, it should be categorical. So it cannot be a continuous variable. So the variable should be categorical. Like for example, car types, car brand, country. So it should be categorical so that you can show the percentage. Each car, what is the percentage of number of owners and things like that. And I think you already know that the entire chart actually represents 100%. So pie charts are quite popular, especially in business communication, because they actually very quickly, we can actually show the summary of the various activities, for example, like sales and operations. And pie chart is also used to summarize survey results. We use this whenever if you're doing survey, how much of resources that you have used. Sometimes on your phone you can actually see the RAM size, right? How much is free, how much is available, memory usage in memory. So it's effective in making such visualizations. So to draw the pie chart, we actually have this pie function. So earlier, if you just put the plot, it plots line. If you use scatter. If you use bar, then it actually plots bar. And now we are looking at pie. So let's try to draw a pie chart showing the world population based on continents. So we are going to create a dictionary object. So that why we are creating dictionary object, remember, we are creating like a multiple attributes name and also the values for each attribute. So let's say this is a continental population, and of course for dictionary object we are using curly brackets. So let's say the first one we have Asia. So this is the value. Can you see? Sorry. This value is not a code, it's actually the number of population. Not necessarily you have to follow exactly the same number. And Africa. It's all in billions. And we have Europe. North America. South America. You can add. You can just simply hantam on this, so no problem. Then okay. So in this dictionary object that we are going to pass, there are two items, right? The key and also the value. What is that you are interested in passing for plotting? It's the values. Sorry, what have I done? Continental population dot values. You want to actually pass the values. And then there is one option known as explode. So this option explode, what it will do, pie charts they have segments, right? When explode means each part has a gap in between. So you can actually use this explode. So it has a much more clearer visible thing, but we have to define what is the spacing for the explode. So we will do that shortly. And we can actually set the label. So what is the label option? So this one, we can actually take the key from the object, from the dictionary object. So this is the continental population dot keys. We take the keys. Is that okay? Then when we want to actually present the percentage, so we can use this option known as auto percentage, and we can define the format, how we want the format to be displayed. So we use percentage 1.1 F percentage. So this part here is actually you are defining the string format on how you want it to be displayed. So you want it to be displayed in the format of point percentage. So it's a float number with the sign percentage. So they are defining how the percentage should actually appear in the chart. And there's also an option known as shadow, and you can set this to true. So it gives like a shadow kind of effect. Remember that we need to define this explode, which is the spacing. So we need to actually define the explodes. So we need to create a series for that. Explode. So because we have 1, 2, 3, 4, 5, 6 categories, so we can define the space for 6. So maybe we can just define as 0.05 for each. One, two, three, 4, 5, and 6. So let's run this. Let's see. Okay, this one has to be straight line. Okay, just hold on. I think. Oh, because we have to import again the. Forgot about that. We have to import back the matplotlib PLT. Still there is error. Let me see what is error. Just hold on. So we just added the matplotlib.pyplot. Missed on that. and you have the plot. So you can actually see the plot in terms of the percentage and each category, and it has the shadowish kind of effect to the chart. Yeah. Oh, thank you. Everyone managed to get the plot? Zoom in to the code or what? So have you managed to get it? Okay, everyone got the plot. So this is what we actually use the explode function, and of course this is the string format of how we want it to actually appear. So it's actually a continuation of the earlier code. It's the same code actually, but that's fine. So next we're going to look at testing assumptions about data. Now we are under the subject matter of exploratory data analysis, and what we have actually gone through in several sessions was that how do we actually plot those data using various charts, right? And each plotting type can be used for certain types of data to effectively visualize them to bring about some meaningful insight. So whenever you have your data, there's some assumptions that you actually you need to check. For example, what are the assumptions? Independence of features. Based on the various attributes that you have, is it dependent or is it independent? Does it have some correlation? Does it affect certain attributes, or it's totally standalone? It doesn't have any effects at all. So all those things are very important, because after this, when we actually want to do for the machine learning, which is the coming towards the final topic, if you want to make prediction of certain attributes, you need to consider all those attributes that are related or have correlation. If it doesn't have correlation, you don't have to waste computing power, so you just can remove those attributes out. So that's why we are also interested to look at whether are the features or the attributes, do they have any correlation or not? And what kind of relationship that it has with the target variable. So what do we mean by features and also target variable? So let's say if you want to predict certain things, maybe the price of the house, because we were actually dealing with the house data set, right? Let's say if you want to make prediction of the house, you want to see the population, for example, what kind of relationship does it have with the price? Does it has a linear relationship or does it have a quadratic dependency on the features? So what kind of relationship that it has? And what kind of distribution does a feature have? Is it equally distributed? Because whenever you want to train data, you always want to have the distribution, a well-distributed features, so that your model is not skewed towards or not biased towards certain range of data. So one of the major objective of EDA is of course to test these assumptions. So how to check these assumptions? We'll use the same USA housing data set. So let us actually try to, we need to import pandas back again. And then we can actually use the housing price, use the pandas library, read CSV. Yes. And then let us try to see the info. So we have already done this before, right? And what other functions that we actually have used besides info? What is the function that you use to see the first 5 entries? The last 5 entries? If you want to see the statistical distribution, describe. If you want to know how many rows and how many columns, shape. So all those things are various functions that you can actually use to visualize. So we are going to try to now check assumptions of normal distribution of the features using this data set. So most of the machine learning models, it makes an assumptions that the data are normally distributed or have a well distributed thing. So how can we actually check? We can actually check by plotting the histogram features. Remember earlier we have done this histogram, we can actually see how is it being distributed, right? So let's see how we can actually do that. So let's try to plot the histogram of all the features. So you're going to have multiple plots here. So plot, we're going to use histogram, and this is going to be on housing price data frame, and we're going to look at, what's the first one? Average area income. So I'm just going to copy the names from here. Average area income. We can actually set the bins as 100, and we can use the label the same, average area income. And this one we can plot, we can show the legend, and we can put on plot show. Now what we're going to do now is we are going to copy this code and paste it. So how many we have? 1, 2, 3, 4, 5. We're not taking the price. We're just looking at this 5. So we take the second one. Average of area, house age. Three, 4, 5. Okay, average of house age. average area, number of rooms, average area, number of bedrooms, and area population. So once you're done, if you try to plot, you'll be able to see. Let me just go out from here. In terms of code wise, everyone able to do it's the same code, right? But you are able to see the distribution of the average area income, which has a Gaussian distribution. Average area house age, it also has a Gaussian distribution. Gaussian distribution means your data is well distributed. So average number of rooms, average area number of room is not well distributed, right? This is a bit different. Area population is also well distributed. Everyone managed to get this option. So you want to take into consideration of those equally distributed attributes. Let's say if you want to make the prediction of the house price, you want to use all those attributes that are well distributed. So this is on the visual inspection. Everyone managed to get? Now we can also check at the same time whether the features are independent to each other or not. What we have actually done earlier, the histogram plot is known as what? Univariate, bivariate, or multivariate. The histogram that we actually draw just now. Is it univariate, bivariate, or multivariate? I did mention that is important, right? Guys? Why no one looking at me? Yes, it is univariate, right? Because you're just looking at the distribution of one variable only, right? But if you want to check the features, the independence of features of each other, which plot that we have actually done before that shows relationship between two? So showing the relationship between two is known as what? Bivariate, right? Yeah, two. So you can actually, we used scatter plots, right, to see the relationship between these two, right? So that's one way that we can actually see bivariate. So how do we actually do? You can actually draw the scatter plot of every pairs of features to try to see what's the relationship. Earlier, remember, we have actually done the plots with respect to price. We can see whether is it positively or linear positively correlated or negatively. So most of the time it's actually linear positively linear correlated, right? Now there's another way of plotting. Instead of plotting every pair of features, it may be a bit difficult to keep on plotting like how we did the histogram, right? Histogram we did for one variable. But if you want to do for all the pairs of the attributes, to do that one by one, it could be quite a bit of a hassle. So one way is you can actually draw a scatter matrix that is actually able to show the histograms of every feature on its diagonal entries. Diagonal means cross sectional. When we do a scatter matrix, it's able to show the histograms of every feature and displays the scatter plot on every pair features of diagonal entries. So if we do this kind of matrix, what type of visualization that we are doing? Univariate, bivariate or multivariate? Multivariate. It's simple, right? Uni means one, bi means two, multi means more than one. So let's try to see how we can actually do this plot. So we're going to import from pandas plotting. This is another library. We are going to import the scatter matrix. We need to import this. So we're going to define we're going to use the function scatter matrix. Sorry, no double T, single T. And we're going to pass the argument, which is the housing price. We can actually set the figure size to 1515 and diagonal. So here diagonal part, there's two options. Either you can use kernel density estimation or you can use histogram, hist. So we have actually used histogram before, right? So just for a change, let's try to use the kernel density estimation, which is similar to histogram, but just for the sake of trying something different. So let's do this plot and show. There. So I managed to get this chart. Let me see if this one's better. Same also. Okay, so this one, do you see that it actually takes, it's actually a matrix. So let me just minimize it a little bit. So you can see that this is price, area population, average area number of bedroom, average area number of rooms, average area house age, average area income. And this is like the cross, right? So if you look at the bottom one, this one, the first one, this is price with respect to average area income. Price respect to average area house age. Price respect to average area number of rooms. Are you able to follow the chart? Then price with respect to average area number of bedroom, price against area population, then price against price. Why price against price you're getting this kind of chart? What is this actually? Anyone able to guess? Why price against price you get something like this? Price against price, why you be getting like this? Anyone? Price against price means what? Is it bivariable or univariable? Univariable, right? What did we do to plot the single variable? Histogram, right? This is actually kernel density estimation, which is also histogram, but it shows you the line. So what does this tell you about price? Guys, what does this tell you about price? We just saw some example just now. What does it tell about the price distribution? We just only did few examples, right, about distribution. What kind of distribution is this? The Gaussian distribution, right? Or uniformly is distributed. That's what actually it means. So it means that you can actually see the when you do the scatter matrix, you can actually see the variable visualization, which is price. Price is well distributed. This is what? What is the second one? Area population is also equally distributed. Average area, number of rooms, is it equally distributed? This is the plot that you get like this, right? It's not. So all the diagonal one is the univariate display. Average number of rooms, also Gaussian. Average house age, also Gaussian, well distribution. Average area income is also Gaussian distribution. Are you following what I'm saying? Clear? Are you understanding what is it happening? Yes or no? So this chart actually shows you that. And at the same time, it also shows you the relationship with other plots. Right? For example, average area income with what is this? This is average house area. So that's one thing that you can see from this scatter plot. Let me make it smaller back again. So what else that you can actually see from this scatter plot to identify whether the features or the attributes, are they actually independent or dependent on each other. So visually when you look at it, if it has the scatter like a circle, if it has a scatter like circle, it means that the features are independent. That means they are not dependent. Which number of features? Where can you see circle? This one, right? This is circle, this is circle. This is circle, this is circle. Circle, 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 circle. This is circle, circle, circle. Right? So what it means? If you look down at the area population and also the average area income, they are not dependent. That means they don't affect each other. They are independent. So you can see the relationship between two variables. I mean, this is what? Univariate, bivariate, or multivariate that we are looking now. Guys, can you all answer something? Uni, bi, or multi? When we're looking at this round circle shape. Bi, we're only looking at two only, right? But if you're looking at the entire matrix, of course, this is multi. And with diagonal is uni. So which means this doesn't have, it's not dependent, it is independent. It doesn't affect. But if you see like an oval shape, like this, do you see this oval shape kind of thing? This means that they have some sort of relationship. Like for example, price and average area income has a relationship, positively linear relationship, right? This one also has positive linear relationship. This one also have positive. This one, this one, this one, this one, and this one. Are you able to decipher the chart? So when you look at this overall, is most of the features, are they independent or dependent of each other? So there are more circles, right? If you count 3, 4, 5, 6, 7, 8, 10. Yes, there are more circles. That shows that there are more features which are independent. They are on their own, they are not dependent. Only some they are dependent. So from this inspection, if we are looking at the price as our target variable, so what are the variables that will affect price? From this chart on your screen, look at your respective screen. What are the variables that can actually affect price of the house? Sorry? Area population, that's one. What else? Average house age. What else? Average area income and average area number of room. Average area number of bedrooms doesn't affect at all. Alright, so this is how you can actually try to identify. Any question up to this point? So we'll try to finish off the last part. This is what we have already done the discussion. You can either set it to current density estimation. This is the diagonal one, or histogram. So if you look at the scatter plots, if they form a circle, they are independent or approximately independent of each other. If you have an angled oval, then the features are dependent. So this is what we have actually found out, that if we look at the price, these are some of the features that are dependent. Now, in order for us to select, sometimes you have a data set, a lot of features that are there, right? A lot of attributes, a lot of variables that are there. And let's say you want to predict the price of the house. So you want to take variables that will affect the price, right? Does it make sense? So that's the whole idea of you doing this. If only these 4 affects the price of the house, do you want to consider other attributes that are not affecting the price? Why? You don't need to. It's not affecting the price, so why do you need to take into consideration? So you might as well just remove those, right? So this is the whole idea. So one final one. So of course, in order to lessen the computational load and achieve better accuracy, we have to identify the most relevant features. That's what we actually did, right? Set of data, and remove the irrelevant, less important features which do not provide value. So you don't simply just chunk the whole data. You select which attributes. So that's what we're actually doing this. So this is known as feature selection. That we try to select the features that are important. And this will affect your performance of machine learning model in terms of the accuracy. So the process of feature selection is meaning to say that we pick the features that will actually affect to the target variables. In this case, the target is the price. So what are the attributes that will actually affect? So another way, that a basic way that we can actually find, just now we saw in terms of visual, right? Round means is independent, oval means, right? So visually you can check. But let's say numerically, if we want to represent that, so we can actually use the correlation matrix feature. So we can use the correlation between features, one of the basic methods, to see whether they are correlated or not. So once we actually do this, you can try to match with the earlier diagram to see whether is it strongly correlated or not. So the correlation is a statistical term that measures the dependency between 2 features as a number ranging from -1 to actually 1. 1 means it's very, very strongly correlated. and go negative means it's negatively correlated. So that's what it means. So if one variable increases and the other also increases, and vice versa, we say that the correlation between these two variables is positive. That means one variable, when it increases, it also affects the other variable. And if it decreases, it also decreases. So that means the correlation between these two variables is known as the positive correlation. However, if one variable increases, the other decreases, and vice versa, we say that correlation is negative correlation. Understood the point? How the correlation is? So the positive correlation and negative correlation. It means it is linearly affecting. Negative means it's reverse. It's not really affecting. So let's use the method correlation. And because when we want to plot the correlation matrix, we are going to use some graphical elements. So for that, we import the Seaborn library. So Seaborn library gives some nice visualization to the charts. So let's do this. So let's import Seaborn as SNS, and we're going to use the correlation matrix. We're going to use our data set, which is house price, and we are going to use the correlation function. Sure. Thank you. So we're going to import the Seaborn, and this is the variable that we actually named to get the housing price correlation values. So we also will use this. We want to capture all these index features. So the index features we will capture using that correlation matrix index. And we'll set the plot figure size as 12 for now, and let's try to actually plot the correlation matrix now as SNS Seaborn heat map. So we're going to use the heat map function. So we're going to use that SNS. Oops, sorry. We're going to use a heat map. So first, what we're actually doing is we're actually getting all these correlation values. We are also extracting out the index of the correlation feature index, which will be used as part of the heat map. So the heat map requires this feature of the index. So housing price index, which is from the feature index, and we capture the correlation value. Annotation. So there's two functions that we need to use: annotation and also the color map. So which means it will give the proper annotation on each boxes on the heat map, and also it gives all these the color choices for the heat map. So annotation means you're going to set annotation as true, so you can annotate each one of it. C map is where you set the color map. So this one is using the red hue kind of color map. Red, RD is red, yellow, green. Red, yellow, green combination of the heat map. Then we can plot show. Let's see if able to get. Yeah. Let me just go out from here. You're not able to get the heat map. So here, if you see, this is all the positive correlation, right? Earlier, remember that this part all it's all circle. Look at this diagram. You see that the circle part, it's all red, right? Negative correlation or not correlated. The positive one is price, and this one. Even in fact, if you look at, just look at this part here. The strong correlation is here, right? 0.64, 0.45, 34, 41. This is almost close to zero. Average number of area number of bedrooms, which you can also see from here, right? It's not that much correlated. But this one, yes, 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 yes. So you can also see in terms of numerical value. Of course, price, if you do with price, of course, you'll get 1. It is the same thing, right? You're correlating with the same. Of course, it has the highly correlated value. So a value that is actually closer to 0, especially like in the red boxes and things like that, it means that the features are nearly independent of each other. But if you see some large prices here, 0.64, which are almost closer to 1, right? That means it's very, very strongly. So out of these attributes, which one is very, very closely correlated with price? Earlier, is it possible for you to see? Maybe a little bit. You can see from the scatter is actually a bit compressed and it's actually elongated, right? But here in terms of numerical value, are you able to decipher which one is strongly correlated with price? What's the answer? Guys, what's the answer? Average area income, right? That's the highest one. So this is how you actually try to identify. So when you want to take into consideration for training or machine learning, you can actually totally ignore this one, the average area number of bedrooms, because it's almost 0. It doesn't have strong correlation. Is that okay? So this is how actually you perform exploratory data analysis. I'll stop the recording now.